Hi everyone. In this video, we're going to be looking at the slide set on fundamentals of data visualization. So if you want to follow along, there'll be some plots created with ggplot throughout the slide set here. And all of the code is made available, but you will need some R packages if you want to follow along and reproduce exactly all the same plots that we're producing here. So to do that, you'll need this tidyverse package loaded, the lubridate package loaded, and also the ggimage package. And note that you may need to install these using install.packages as well, if you don't already have these packages installed. So the first plot we're going to look at here, again, you should be able to copy this code entirely after loading the packages, submit this, compile this, and produce the same plot. This first part of the code here is grabbing data from GitHub on animal shelter adoptions from a animal shelter in Austin, Texas. And then it's cleaning it up a little bit and then creating a scatter plot showing animal adoptions across time. Here you can see the adoptions peak in the summer months in July, then it starts to decrease back down. And there's this interesting trend that there's a peak in October. So when you look at the same data for dogs at the animal shelter here, you see this similar trend with an increase in the summer and then a decrease during the winter. But you don't see this particular spike in October, which is interesting. And so if you looked at the code carefully, you might have noticed the animal type was filtered to cats, so subset to cats. So this is actually, which we can make more clear using the geoimage function from the ggimage package. This is adoptions of cats. Okay, so ggimage is a fun little package that allows you to specifically plot an image instead of points in a scatter plot. And so this is actually an image of a cat named Marcus from the Austin Animal Shelter there, who was up for adoption, and they had his picture on their website. So it's kind of neat. You can plot whichever image you want right on your plot. Here we can see the trend in the cats adoptions at this specific animal shelter. Okay. So just showcasing a small fun thing you can do with ggplot to start off here. There's lots of specialty packages like ggimage that add a specific set of functionality to ggplot, sort of extending what you can do. There's a package called gghighlight that allows you to, if you have many groups in your data set, many different lines, you can highlight a single one or two if you want to put a point of emphasis on those two groups and make them stand out among the others. That's an example of another specialty package. There's GGI, I believe it's GGI graph. GG network. Right. So there's lots of different packages. This one's specifically for making network plots of networks like this. Okay, these are called networks or graphs. So anyway, lots of different specialty packages like that. If you're ever wondering, how can I create blank type of plot in ggplot? Typically, if you Google it, that's already available in ggplot, or someone made a specialty package for it. So there's lots of different types of things you can make. So before we talk about ggplot more specifically here, we'll just talk about best practices of data visualization, sort of very generally. So putting R programming aside, this is just talking about data visualization in general, regardless of whichever software you're using. So some general do's and don'ts, things you should do and should avoid when creating data visualizations. The first is when creating a data visualization, we want to have our plot be accurate. We want it to show what's truly going on in our data set. So we don't want to mislabel things. We want our axes limits to be sensible for that context. If it's a percentage, maybe the axis limits should be 0 to 1 or 0 to 100%, however you want to view it, for example. So being truthful to the data that we're working with. We also probably, something that is more important to pay attention to as we, of course, try to make our plots accurate. But an important consideration that's more easily overlooked is making our graphics or plots quickly understandable, or in other words, efficient in representing our data. So the whole point of a data visualization is to quickly and efficiently communicate what's going on with typically a tabular data set, a data set with rows and columns. The point being, it's difficult for us as humans to look at a huge table of data and to make sense of all of those numbers. So a data visualization is serving as a way to quickly communicate a point to a viewer who's not familiar with the data set, or even ourselves to better understand the data that we have. So how fast our plot allows others to understand our data is an important aspect of how successful or effective our data visualization is. We also want to create visually appealing or beautiful plots. Okay, so we don't want the aesthetics or colors customizations of our plot to sort of detract or take away from the main message that we're trying to show. So I like to give this example of like my own particular tastes. I'm not a very big fan of like the 1960s color palette. Okay, so this color set, not so great. Maybe using a different color scheme than something like this maybe looks a little bit better, or like neon green and hot pink, maybe not the best colors because they can be a bit distracting. And that's just my opinion, but always keeping that in mind. Another important consideration that's sometimes overlooked is being cognizant of your target audience. So who are you making the data visualization for? Is it for a business manager who does not have maybe as much quantitative experience versus are you making this for your manager who has a background in data science or statistics? The type of plot you would make for either of those people would be different depending on their backgrounds. Okay. If someone doesn't have a very quantitative background, for example, including statistics like the kurtosis or standard deviation maybe are not a great choice in the data visualization itself. And also maybe more complex data visualizations are not a great idea. Maybe sticking to more standard ones like a bar chart or a scatter plot are sort of the go-to. Okay, but if you have a data science manager or fellow statistician, maybe who you are presenting this to, you can maybe get a bit more complex and include some statistics like the standard deviation, standard error, if it would be sensible to them. So it all depends on who you are presenting this to, your given target audience. Other important considerations of some things not to do when creating a data visualization. So kind of going along with making sure your data visualization is accurate. In the same light, we don't want to misrepresent the data or obscure it either. So misrepresenting sort of goes along with accuracy. obscuring our data. So we don't want to, that sort of goes in tandem with potentially overwhelming our viewers with too much going on in the plot. So with a scatter plot, for example, you can showcase two variables at once. So that's two dimensions. We can add additional variables to the plot by adding coloring of the points. That adds an additional third variable. You could change the shape of the points by an additional fourth variable. Okay. But as you start to add more complexity to the plot, this can overwhelm the viewer, make it difficult for them to come away with a clear message from your plot. So in general, it's good to stick to one or two main takeaways that your plot is showing at most. If you want to communicate more than that, it's probably a good idea to create a separate data visualization rather than trying to pack it all into one. Okay. And so someone working for Novartis, a large pharmaceutical company, created a set of guidelines for best practices in data visualization for within the company to help unify how everyone was creating data visualizations there. So the font is a little bit small here, but this is located or can be found. It's linked to on Blackboard as well. Okay. And in particular, sort of looking at some key things in this that I found especially useful, okay, with some of their points on use of color in plots. Okay. So I was guilty of this quite often and still am. I catch myself sometimes. And that one thing we want to keep in mind is that we should not add color to our plot if it doesn't communicate any additional information. So for example, when making a bar chart, you would or should have the labels of the groups for each bar already written on the plot. And so by coloring them separately, this doesn't convey any additional information. So it's better to use a single color since the groups are already labeled for the bar chart. The reason being, if you add color and it's not necessary, it's not communicating anything extra, you might leave your viewer wondering, well, what was the point of that color? Or what am I supposed to be taking away from there being different colors? Like, is it meaningful? So anytime there's lacking clarity in your plot, that's not a great thing. So we'll just stick with one color when possible, unless it conveys extra information. And so on that note, looking over here, sometimes color is useful when it can communicate or convey extra information. So for example, suppose this plot shows quarterly profits for your company. So we have each quarter, and maybe when it's below the horizontal axis here, it's negative profits, and above here, it would be positive. We could use color to bring attention to the fact that these quarters had negative profits and these quarters had positive profits. Okay. Color is effective there and useful in that it's highlighting that difference between the two. So it's good to use in those types of situations. Another aspect in which we want to be careful of color when creating visualizations is in terms of consistency across data visualizations or even within one. So if we had two studies here we're showcasing and we had treatments A and B, we should keep the coloring consistent. If the treatment A is the same in both cases and treatment B is the same in both cases, we should use the same blue for A both times and the same red here for B both times. This keeps things as clear as possible, helps our viewer understand what's going on more quickly and efficiently. And it may sound very clear, like, of course you would do that. But it's easier said than done. So I've run into this with a study. For example, I made some box plots for a genetics study that I was on in grad school, and I made many data visualizations for our research paper, and accidentally I swapped two of the colors for the groups in the box plots. And regrettably, that was published. So it still bugs me to this day that I had the same colors used throughout, but they were swapped across the groups. So it was inconsistent in the paper and how it was used. So this is something to always double check and be careful of, just for consistency in how you're representing groups with colors. Another aspect with how using color can be helpful, like we saw with that GG highlight package, if you have many groups or lines for many different groups, you can use color or bolding to highlight a specific group to bring emphasis to that. Say this is some sort of productivity metric where you have each line is the productivity of a different employee at your company over time, and maybe you're the line that's bolded here, you're represented. So maybe you're giving a presentation to your boss about why you should get a raise. So you're bringing attention to your line and showing how it compares to other employees in the company. Okay. That's just one example. And lastly, another important consideration when using color in plots is to not obscure. The issue here is that if you use grid lines with too much ink, the lines are too thick. In this scatter plot here, it can obscure the points or cover up your main point a bit. So the scatter plot, typically you're trying to show the two-dimensional points here that are plotted. So you don't want to cover those up too much. So you want to use either softer grid lines here, or if you can, some people advocate for completely getting rid of the grid lines behind the points and just having the points in plain white space. I think that's a great option as well. This is something you have to be particularly careful about with ggplot2 because there's a lot of there's grid lines typically by default in ggplot2, and a lot of people are not a big fan of those, but they can be removed by specifying certain options. So that's some considerations for best practices for data visualization. Other things to consider separately, sort of putting the programming aspect of data visualization aside for now, is that it's important to be able to know or understand the type of variables that you're working with so that you can know which data visualizations are most appropriate. Okay. So R, as a programming language, and other software tools as well, won't necessarily guide you in the right direction in terms of which plots to make. It won't say, oh, you shouldn't have made a pie chart here. You needed to make a histogram because it's a numeric variable. Sometimes it will finagle things in a way that it will create whatever plot you ask for, regardless of if it's appropriate or not. So it's important to be able to understand which types of plots you should use. And to do that, we need to be able to identify the types of the variable that we're working with. So we'll cover this very briefly because this isn't the main focus of this class. But generally, the type of plot you're going to select depends on if it's a numeric or a categorical variable. So numeric variables are variables such that arithmetic operations are sensible. So addition, subtraction, multiplication, and division. So examples of that, of numeric or quantitative variables, measuring someone's height in inches, their weight in pounds, their age in years, or say the number of pets that they have. These are all examples of quantitative numeric variables. Categorical variables, which most commonly would show up as character strings or factor type variables in R. Some examples of that, measuring someone's genotype. So maybe they have one of 3 possible genetic signatures. Someone's handedness being left or right-handed. Measuring whether someone is a Netflix subscriber or not. And then an ordinal categorical variable is an example of one is someone's class standing, if they're a student. So whether they're a freshman, sophomore, junior, or senior. There's a particular ordering to these categories, but it's still a categorical variable. It's not numeric. Okay. And again, that being because not all arithmetic operations make sense. A sophomore times a sophomore is not equal to a senior. We can't do that type of mathematical operation in a sensible way. Some types of variables are a little bit trickier in terms of whether they're numeric or categorical. So one example is rating of agreement from 1 to 5, where say 1 is strongly disagree and 5 say is, so yeah, let's say we have 1, we have rating of agreement where 1 is strongly disagree and then maybe 5 is strongly agree. 2 mostly disagree. 3 neither agree nor disagree. 4 mostly agree. Okay, so this scale of rating of agreement, maybe the variable is encoded or recorded as being these numbers 1 through 5. R wouldn't recognize that this really should be a categorical variable. It will let you do division, multiplication between these, right? It will let you make a histogram of this variable, okay? Even though it's not appropriate to do so here. This is a categorical variable. It's an ordinal categorical variable, but it's categorical. So we should not create like a histogram or a box plot. Instead, a bar chart or a pie chart, categorical visualizations like that are what's appropriate here in this case. And again, the reason being this is categorical because it's not the case that you can say mostly disagree times mostly disagree equals mostly agree. That type of math doesn't make sense here. Or the difference in agreement between someone who strongly agrees and mostly agrees, we can't say that. We can subtract those and say that's exactly equal to someone who mostly disagrees. Or I'm sorry, strongly disagrees. So we can't do that type of arithmetic operations with this type of data, so it's categorical. All right. So given that you can identify whether it's numeric or quantitative, or a categorical or string character variable you're working with, or factor in R, you can then select which type of visualization is most appropriate. So if you have a single quantitative or numeric variable, for example, a histogram or a box plot is a great visualization to use. Those are the most common. If you have two quantitative variables, a scatter plot or a line chart. So a line chart is pretty much the same as a scatter plot, but you connect the points across time. Okay. For a single categorical variable, a pie chart or bar chart is a great visualization. Tree maps are not very commonly used, but that's another type of visualization for categorical data. And geographical maps, those are very useful and increasingly common these days, now that we have more and more of what's called spatial data sets. So data sets that have spatial location recorded as well for each observation. So ggplot has some great methods for spatial visualization of data. So for example, here's Michigan and there's county level data. You could map and then it's got longitude and latitude as the axes. You can map a categorical variable and color each county based on the value of a certain variable. That's called a choropleth map. So choropleth choropleth map. So that's a type of data visualization that you can make. These are all choropleth maps. You can also map a continuous or quantitative variable to these and do the shading of a certain color based on that third variable. Okay. But unfortunately, although maps are very cool, and there's a lot of great options for doing that in ggplot in R, we won't be covering that this semester, but just know that that's a great option that's out there. Okay, so pivoting to talking about ggplot2 more a bit. So this might be a bit of review, but talking about the data argument, how we specify that with ggplot2, how we can specify aesthetics like the color, the fill, the X and Y aesthetics. We can specify all of those typically in the AES function in ggplot, and how we can use different geometries depending on which type of plot that we're trying to make. So as a reminder, geom histogram for a histogram, geom point for a scatter plot, those types of things. So as I mentioned, most commonly, as we may have seen, we specify aesthetics inside of the AES function, which stands for aesthetics. Most commonly, we're specifying the X and Y aesthetics. And if we want to add additional dimensions or variables into our plot, we can use other aesthetics, such as the color and fill aesthetics. So color, we've seen how that can help us color points in a scatter plot. Fill aesthetic is similar, but used for other types of plots. So if you want to change the color of the inside of a box for a box plot, we do that using the fill aesthetic. Whereas the color aesthetic for box plots changes the outline, the color of the outline of the box. And similar for a bar chart, the fill aesthetic controls the inside coloring of each bar, whereas the color aesthetic controls the outline color of each bar. So there's many other types of aesthetics besides X, Y, color, and fill. In fact, there's so many we can't talk about all of them just here in these slides. The alpha aesthetic controls the transparency of points. You might have lines for like a line chart. Maybe you have several lines for different groups and you want to differentiate between groups using a different pattern for drawing the line, be it dotted, dashed, or solid. You can also plot, instead of points in a scatter plot, you can plot words or letters using geom text rather than geom point. We can change the size and shape of points in a plot to show additional variables, and also the position, how those plots are positioned in the plot. Okay, there's many, many aesthetics, and there's so many that you don't really, I wouldn't say most people learn all the aesthetics and then create whichever plot they need. You know, typically you would be seeking out a particular aspect of your plot that you're hoping to change or update. And so you Google that and figure out which aesthetic you need to do that. So here I linked to a couple of resources that showcase a lot of different aesthetics that are available. Okay. So they show some examples. Here's the different line types you can specify. The different shapes of points you can specify, all kinds of things. Okay. And there's a couple different links with those different aesthetics available in ggplot2. So separate from aesthetics, there's also the options in terms of geometries. So geom point, we've seen how we can use that to create a scatter plot to visualize the relationship between two quantitative variables. Geom smooth is a function you may use in tandem with geom point a lot. It adds a smooth line of best fit for two numeric variables. So if we look, for example, real quick, let's load like the Palmer Penguins data set. Also the tidyverse. We load those two. We can create just a plain scatter plot to start. Just as an example, we'll do body mass, and then we'll make y the flipper lengths of the penguins. And then we'll add a geom point to make a scatter plot here. Just a basic scatter plot. Okay. So that's what geom point does for us. Geom smooth adds a smooth line of best fit, showing the trend in the data here. So we can add this geom smooth. And so it adds ggplot, as a reminder, sort of builds things up layer by layer. So you start with your blank canvas, it adds points, and then on top of that, so you'll notice the line is drawn over the points, we add this geom smooth layer. So alternatively, you could add the line first and then draw the points on top of it. Notice now the lines are above or plotted on top of the smoothed curve, depending on how I drew it. Okay. Either way is fine. It would just be a style preference. But anyway, so geom smooth draws this smooth curve through the data, but note that it's not perfectly straight. So if this were a simple linear regression line of best fit, this line should be perfectly straight, but it's not. Okay, so if you want to see exactly how geom smooth works, you can open up the help file for it. And then if you skim through it, you'll see here in this method argument, it defaults to using this stats low-s function. So if you click on that, and it describes how it's creating that curved line of best fit. So it says a polynomial surface is fit determined by the predictor variable using the low-s function. So that's how this is fit. It's not a simple linear regression line. But ggplot is always very customizable. So if you want to make this a straight line of best fit from a simple linear regression between the two variables, in geom smooth, you can do method equals, and then in quotes, LM for a linear model. Now it fits a perfectly straight line that's a linear regression line between these variables. And there's lots of options for specifying this line through the data. One more option I'll point out, because people commonly want to do this, the function geom smooth also comes up with standard errors for the line of best fit that automatically are plotted around it. If you want to suppress that, you can add this option SE equals false. So now it just draws the line with no standard error bars around it. Or sorry, standard error bands. Okay. So that's how geom smooth works, which can be a little bit handy with in tandem with geom point. There's also geom histogram that displays the distribution of a numeric variable. Okay, so we would only specify one variable, the x, and histogram. So the geom histogram is one of my least favorite geometries out of the box of ggplot. I don't care for how the bars are sort of all smushed together, and there's no color differentiating between the bars here, but that's important in a histogram. So how we can sort of fix that up is inside geom histogram, we can say color equals white to sort of give a border to the different bars. And it makes it a little bit better looking, I believe, in my opinion. I also don't care for this little bit of extra space here because histograms, of course, the bars theoretically cannot go below 0. So there really should not be this space in the plot, I feel like, as well, in my opinion. But that's something you can customize in ggplot as well. But anyway, so that's just me ranting about geom history bits. But it's still great that it's available. Geom box plot. Okay, so similar situation where you have single quantitative variable. By default, it makes a horizontal box plot, but you can make it a vertical box plot by adding this layer chord_flip using that function. That flips the box plot to be vertical instead of horizontal. Again, just a stylistic choice. And you can control the fill or color of the box plot if you want with the color aesthetic. Okay. Oops. Oh, actually, that controls the outline of the box, right? It's the fill aesthetic controls the fill of the box. Right. All right, and then geom bar tallies or shows the frequency of different levels of a categorical variable in your data set. So for example, in the penguins data set, we had all these variables. We had the species of the penguin. We can make a bar chart for the number of penguins in each species in this data set. All right. So that's some examples, but there's many other geometries that are available. These are just some of the most commonly used ones. So I link to it here. This gives, again, just some of the many, many different geometries that you can make or use in ggplot. So just like with the aesthetics, how I mentioned, there's so many, I think it's unreasonable to expect to learn them all. What you'll do is, as you need one, as you want to create a certain type of plot, you would just Google it. So for example, how to make scatter plot ggplot2. And then someone, there'll be a good blog post somewhere about, like our bloggers is pretty good, that shows you how to create a scatter plot with ggplot2. So looking at applying this to real data set besides the penguins one here, if you want to follow along, this is going to be using a data frame called SimData. And if you want the code to create this simulated artificial data set, you can click here. And this gives the code to create this simulated data set that we're going to be working with here. So we have some variables. This is like a fake data set on students, their age, their weight, their height, number of pets that they have, if they subscribe to Netflix or not, handedness, some specific genotype, some fake made up variant, genetic variant. Okay. So first, here's the code for making a scatter plot. So again, using geom point. And then we can modify some of the axis and labels and overall title using labs. And so it looks like this. So that's a bit of review. We already looked at how to do that. Again, adding a smooth curve through the data, we can add a geom smooth layer to that previous scatter plot. Okay. So here's this code to produce that. That can be helpful for, again, showing the trend in the data, especially if you want to show a linear regression line. That's often something you may want to do. Histogram, which we looked at for the penguins data set as well. So here's how you can specify the outline color of the bars in the histogram, and then a different color for inside the bars of the histogram. And then again, specifying the axis labels and overall title. So here we can see like this distribution of heights for the students is fairly bell-shaped and symmetric. This was actually simulated. Let's see if we look at this code that was used to simulate the data. The height was simulated. Yes. So the height was simulated from a normal distribution. So this is actually what truly normal data looks like for an empirical data set for just a sample. So you don't ever get this, you don't commonly get a perfect bell shape. It might look something like this. Box plot of that same, well, looking at the age of these simulated students, okay? So we can see the median age in this data set was roughly 21. The third quartile was about 22 years old. Looks like the max was about 25, the min about 17. Okay. So it's a box plot, another good data visualization for a single quantitative variable. And then this last plot, so there's a bit more going on here. And here, this is creating side-by-side box plots. Okay, so we specify the x variable being the group that determines each box. Y is the response or quantitative variable. And then I'm coloring the boxes here based on the group, but according to that Novartis best data visualization practices, I should not do this. I should keep it a constant color across the groups since they're already labeled. So showing how I still have room to improve to follow that best practices of data visualization guide there. Okay. And then here I'm manually specifying the colors for each box based on this colorblind friendly palette or set of colors. And other aspects. So here's what it looks like. Sometimes with ggplot, when you have the group labels like this, if they're long enough, they might be overlapping each other. So ggplot sort of prints them all on there, but it doesn't check if they're overlapping or not. So it can be beneficial to angle them so that they don't overlap, which looks bad. So I avoided that, or I angled them, the labels for the groups here, by using this option, axis.text.x, in the theme function. So most everything you want to customize with ggplot, which we'll look at a little bit more next in a later video. Almost anything you want to customize like that, like the rotation of labels, the font size, things like that, all of that can be customized inside of the theme function, which is typically the last layer that you add on to your ggplot, is this theme function. I also suppressed the legend from showing up at all using this legend.position equals none option. So otherwise there would have been a legend showing up that said which group belonged to which color. So I suppressed that here. And then lastly, I reordered the groups based on the age of them using this code here, this reorder function. Okay. So I rearranged the classes, what order those were in, based on the age of each student. All right. So another example of a plot we can create is a bar chart. So again, this is useful for visualizing one categorical variable. So here, did a good job keeping the bars all of the same color because it doesn't convey extra information. So we can see most students are freshmen in this data set. The next most common is for students to be sophomores, and then juniors and seniors, and so on. Okay. So a bar chart, typically you want to arrange it in descending order like this, where you have the tallest bar going down to the shortest for each group of the categorical variable, with the exception being if your categorical variable is ordinal, if there's a particular ordering to the categories that's not based on the bar height. In that case, you should order the groups based on that particular ordering. So for example, again, if you had ratings of agreement, so it was strongly agree, maybe it was the first group, and then you go all the way, the last group being strongly disagree. Okay. The bars for each of those might be varying in heights, but because there's a particular ordering to those categories, we should keep the bars in that order in the plot. It would be confusing for the viewer to mix them up and sort the bars by height. So that's the exception. But otherwise, I think it's best practice to sort the bars by descending height. Okay, so we mentioned earlier how sometimes it's helpful to visualize a categorical variable with a pie chart or a bar chart, but they both sort of convey the same information. So looking at the same exact information with a pie chart, which we'll make with this code, which is very similar. It also uses geom bar, but it adds this chord polar layer. This is essentially what turns this plot into a pie chart. It lets ggplot know we want a pie chart. Okay. This conveys the same exact information as that bar chart. Okay. But generally, a bar chart is preferable, is more preferable than a pie chart. Okay, the reason being, these are conveying the same exact information, but looking at the bar chart and thinking about efficiency, how quickly our viewer can understand the main takeaway from our plot. The bar chart makes it very quick and easy to see that freshmen are the most common class for the students here. Seniors are the least common, and then sophomores and juniors are in between. We can see that very quickly glancing from left to right. It's easy for humans to differentiate or distinguish the heights of the bars from one another. There's been like research done on this, like people time how long it takes humans to comprehend the differences in the groups. And bar charts are very good at that, doing that efficiently. Pie charts, on the other hand, we can see that freshmen are the biggest slice, although one issue right off the bat is that the viewer has to look over here at the legend and then look back at the plot to see, okay, that's freshmen, then look at the yellow, okay, that's sophomores, seniors, juniors. Okay, so that takes a little bit of extra time. Although in the pie chart's defense, you could say, well, you could put the labels right on the plot. So have the word freshman, sophomore, senior, junior. Yeah, and you can do that if you don't have too many groups. Okay, in this case, there's only 4 groups, so that's not too many, so we could do that. As you get more slices, the font size would be too small. So you would have to use a legend, which forces people to look back and forth, and that's inefficient. Yeah. Another aspect that's not great about pie charts, if you have 3 groups here like this that are similar in size, it's very difficult for humans, to determine which group is the biggest or smallest, or if they're different at all. In this case, these 3 slices are so similar, they almost look the same in size. And again, playing devil's advocate here, in the pie chart's defense, you could say, well, you can put the percentages right on here, or the frequencies, and then that would make it clear which group was smaller or bigger. And yes, that's true, but then you're having your viewer read numbers, and they'd have to read them for all of the slices. Again, if you have many slices, that's not great. Especially if they're too small, then you can't write those percentages on there. But even when they're not, you're having your viewer read the percentages, which is a little bit slower than looking at the heights of a shape like this. It's just faster for the bar chart. And again, coming back to the main point of data visualization is to communicate our data quickly and accurately. And so the bar chart just simply wins in terms of efficiency, how quick it is to understand it. That's not to say that the pie chart's wrong. So there's nothing incorrect about a pie chart. It's just not as efficient is all. And a last point about this. So of course, if if a supervisor asks you to make a pie chart, I'm going to make a pie chart. I'm not going to explain to them, oh, here's why a bar chart is better, actually. If someone wants a pie chart, gladly give them a pie chart. This is just talking about the case in which you have a choice. You're the one deciding which data visualization you get to use. I would say in that case, always go with the bar chart instead. So that's it for a brief talk on fundamentals of data visualization. There's also this activity we can look at using Swirl that covers ggplot2. Okay, so it introduces us to ggplot2. And note that a lot of this activity uses this qplot function, which stands for quick plot. This is a function that was meant for people who are newer to ggplot. It sort of simplifies a lot of the selection of the geom function that you end up using. It automatically selects one based on the variable type you're using. But it's still, this activity, this swirl lesson gives a lot of good introduction to different parts of ggplot. So even though we're going to be using the ggplot function rather than qplot, this is still a good intro activity for ggplot2. Okay. So take a look at that swirl activity. And then also just some reminders about upcoming due dates. So homework 2 I linked to here. There's a quiz 3, which covers ggplot2 concepts based on the reading. And then lastly, some readings from the online textbook ggplot2. So thanks, and that's where we will end for today.